Hello everyone, welcome to the webinar Practical Approaches to Getting Quality C++ Codes. My name is Nuno Castro and I'll be your speaker for today. A little bit about me. I'm the product manager for Visual Assists. I have a computer science degree, 10 plus years of experience in IT. I'm a clean code and TDD enthusiast, and I firmly believe that every company should improve people's lives. On the slides, you can also find my contacts, nuno.castro@hotmail.com, and my LinkedIn profile. So feel free to drop me a message or an email if you have any feedback regarding Visual Assists, as I'm always willing to talk a little bit more about it. At Whole Tomato, we are currently on a mission to find and eliminate the coding roadblocks between developers and their ideas. We materialize this by doing a Visual Studio plugin called Visual Assist. Visual Assist lets you create better C++ codes, and we will be releasing a new version anytime now. So feel free to check our website as we will have more news soon. Before we get to the actual contents of the presentation, there's a story and a message that I would like to share. So first on the message is, if you think a little bit about it, the modern day world is run by computers. We have computers everywhere. We have computers in our cars. We have computers at restaurants, at our homes, at the hospital, at every single place that we go, there's a computer there. And if there's a computer there, there's code. We, as programmers, are writing the code that runs the world. And this is a very powerful thing. So, as programmers, we should have the moral compass to write good quality software. And I say this because if you think a little bit more about it, every line of code that we write has the potential to change someone else's life for the good or for the bad. So it's really, really, really important that we as developers really care about writing good quality software. Now for the story part, and this is a story of a little bit of the story of my career, and is the story of how I met, of I have encountered three different approaches of doing software development. On the first approach, it was design thinking on my first job experience. And with design thinking, I'm not going to talk in any of the details of these three approaches, but the thing that I want to mention is on design thinking, we kind of do some kind of upfront analysis and we designed a little bit ahead, just enough for us to get started. While on waterfall, we tried to design everything up front and have every single detail figured out before we even touch a line of codes. And then it came agile, where we were basically thinking 2 weeks or 1 week, depending on the side of the string ahead, always thinking on the immediate solution and not having the big picture. And the truth is, with every single one of these approaches, there's one thing that I had in common. After 1 year or 2 years of writing a piece of software, even if I started it from scratch, there was a point in time where the team would come together and say, you know what? This will be better if we started from scratch, because at the moment this code is a big ball of mud. It's a spaghetti code, and if we change something, there's a potential to break something somewhere else. And this got me thinking because this was happening time after time after time after time. And of course, there's also a component of me at the time being a more junior developer. But the truth is, when I was talking with other developers that were more senior, they were facing more or less the same issues. So what was going on here? And there was a point in my career that I came across a book called Test-Driven Development by Example by Kent Beck, and that shined a light in my head. And that light was the real reason that I was afraid of changing code and that my code had bad structure was because it lacked testing. So in this talk, as you might have noticed, I will be more in favor of doing test-driven development to take the test-driven development approach, but doesn't necessarily mean that this is the best approach and the one that you should take. Others are valid too, but on my personal opinion, test-driven development is the best approach there is out there at the moment. So what is test-driven development? Test-driven development is a different approach to software development. Is a different way for us to build and structure our code. But from my perspective, the real genesis of test-driven development is in the red-green refactor cycle. What this cycle does and what we are supposed to do in this cycle is the red phase is we write the failing tests. Then we have the green phase where we make it pass, and we make it pass with the minimal viable code, let's say. And then we refactor. We refactor the code to the desired state that we want. And after this, we do it again and again and again and again until we have reached our desired outcome. And while doing test-driven development, as you might have noticed by now, we try to focus on very small increments. We try to do things very slowly, step by step. So along the way, as we are coding, we will get a better sense of the task that we have in hand, and then with this information, make better decisions regarding our software. Other very important step of test-driven development is immediate feedback. It's very important that our tests run fast, so at a touch of a single button, we will have the feedback if things are running the way they are supposed to. Of course, that there are other benefits of TDD that I'm not going to talk them in detail for this webinar, but feel free to drop a message in the comments if you would like to hear more in depth about the details of test-driven development. But don't worry because we will have a practical section straight away. For this practical session, we will be doing the example of the Mars rover. The rules of the Mars rover are very simple. So the plateau has a grid of 10 by 10. The rover has a position that has x, y coordinates and a direction, north, south, east, or west. We have move commands, left, right, and forward. If the rover reaches the end of the grid, it wraps around, and the grid can have obstacles. However, for this presentation and for this webinar, we will just focus on test-driven these two parts, as otherwise it will take too long. Before we go into the actual exercise, just would like to give some kudos to Coderance, as I actually took inspiration to do these parts of the webinar for some material that I already have that I totally recommend that you check. Besides that, feel free to follow any one of these awesome software developers. Kent Beck, the father of TDD, Sandro Mancuso, the big man at Coderance, Valentina Kupak, and Daniel Moka, two software developers, younger developers that are very knowledgeable in these areas that I totally recommend that you have a look at them. And without any further ado, let's jump into the exercise. So for this exercise, we'll be using Visual Studio 2022, and A quick note, if you hear my keystrokes, sorry about it, but my keyboard is a little bit loud. So for this project, what I did was within the same solution, I have two projects. The Mars rover project, where I will be having my source files and header files and everything related to the project itself. And a second project that is a Google test project, where I have a folder where I will have my tests. At the moment, both of them are empty with just boilerplate code. This is the boilerplate code you get when you create a Visual Studio Console app. Let me get rid of it. And here you have the tests CPP file that is also boilerplate when you create a Google Tests project in Visual Studio. So now let's go ahead and get started. First thing that we want to do is think of what is the first test that we want to run. And in this case, I think I'll go with, I kind of expect that we will have some kind of rover variable that has an execute method. And for the first test, I want to check if the initial position is where it is supposed to, that is at 0, 0, and facing north. So here I would say rover tests, and it show position is at 0 and facing north. So at the moment, this probably won't even compile because we don't have a rover variable. So what we want is something like this, and now we are missing the over object. So let's go ahead, right click, add new item, C++ class, let's call it rover class. Everything looks fine. Okay, he created for us the header file, the C++ file. Let's have a look at the contents. Okay, so we will be wanting something like public right, execute right and execute. And now let's use handyva to create implementation. And for now, this method can do nothing. We'll go back over to our tests and we will include our rover, and we still have an error. Void. Oh, okay, I know. So it's a void type, and actually we needed to return a string. So let's go back to rover and std string here. We need to include stream. We need to include string, and we need to update this here. Execute, and let's make it to return an empty string for now. So if we go back to our tests, now We have a rover, it's included, it doesn't give us any error, so I think we are good to go and run this test and see what it gets. All right, a failing test. It says that we returned an empty string and we expect 00 north. So let's go ahead and fix that. So this is the red phase of the TDD. So we can go over here and I'll just say that this is 00 north. Right, sounds about right. So now if I run the test again, voila, we have our first running tests and passing tests. So let's go ahead and do a new test. And now what we will be wanting to check, let's say rotate right. So for right rotation, we will be wanting expect rover dot execute so to rotate right, I need to give him the command R. So it will rotate right once. And what I expect as a result in this case is that it will still be on 0, 0, but now instead of facing north, it's facing east. Okay, so here we need a rover variable. Rover. And we have an error. Let's see what it is. Too many arguments. Alright. Why is that? Because we need an std string here too. Command. std command. And now in theory, our test should run and we should get a red test. Build errors. Why? Okay, because this first test now misses an argument. So let's give him an empty string. And as we expected, two tests, one failing. That is this one that says it returns 00 north and we expected 00 east. So now let's go ahead and go to our rover and fix that. If command right, then return 0, 0 east. And for now I'm happy with this code as I expected to make our tests pass. Alright, perfect. Two passing tests. But now what we can do is, if you look at this test codes, you will start seeing a pattern here. That is, I will probably need to instantiate a rover all the time. So what we can do in this case is we let fixtures that in Google Test we do the following way. So class rover tests, and then this class will inherit from a Google Test class called testing test. And in this case, I don't need any of this and nothing of this too. I can just delete, and what I need is a protected variable called rover, and now I can get rid of this. But now I need to use the test fixture macro instead of the normal test macro. Alright, why is he complaining? Did I miss something? Don't think so. Okay, the problem was with the name of the class. Got it. So let's move ahead, and now we should be able to have our passing tests again, and with less boilerplate codes. So now for the second test, what I will want is to test exactly the same thing, but turn it right twice. And if I turn it right twice, what I will be expecting is, so north, east is south. So if we run our tests now, we should get our failing test. Exactly. So let's go ahead and fix that. So now what I will want, I have a command R. Okay, I want to iterate over my list of commands. Let's go. Commands, and now if command equals R, then I want, okay, I will need direction variable that can be associated to north, that is the default value, and here I would say that if direction equals north, then I will want direction to be equal to east, right? And else if direction is equal to east, then direction equals south. So let's see what I've got here. I have a direction, I iterate over the command. If the command equals R, then the direction equals N. Alright, and here in the return, I probably know what I want is this plus direction. So now let's go ahead and run our tests and see what we get. Alright, so two failing tests. Why? Is returning an empty string. Returning. Okay, I know why. Because here we need actually to do this. String and one direction. Let's run our test and see what it gets us now. One test failing, the other executing. So on two R's, rover executes twice right. It gives north and it's supposed to give south. So it will go here. Ah, okay, I know why I did wrong. Here is not command, it's actually the C, and here you need to compare it against a shard and not a string. So now, in theory, everything should be passing. And that's right, all green. So if everything is green, we can now move to the other tests. And the other test is if I execute the command of turning the rover 3 times, so right, I expect the rover to be at 0, 0, so not east, south, east, west. But before we go ahead and try to fix this test, two things. So make sure we have a failing test, which we have. And the second part is, you see how this is getting repetitive? Actually, we can do this a little bit better by using parameterized tests. And for that, what we need to do is pretty simple. instead of inheriting from this class, we will be wanting to inherit from tests with param. And now I'm going to say that the params is, in our case, a pair of two strings. All right. And now here, instead of using this macro, we will need this macro, and test case P exactly. And now what we will do is call it, let's say, rotation tests, rover test, this class, and our testing values will be what? And stud pair, right? So I want a pair that on the first param is the command, so right, and on the second param is what I expect. So in this case, what I expect is 0, 0, east. So now let's go ahead and repeat that a few times. So now it's RR, and what I expect is south, right? And the one here that I expect now is west. So let's go ahead and get rid of the others for now. Okay. Does this seem about right? Space. Let's see. And here we will get to that after. What we will need now is std string, let's say input equals get param dot first, and the second one is let's call it expected get param second. And here now what I will do is I can delete those and use the input, and here expected. Why is this test, this error? Let's see what we get. It's a syntax error. Values. Oh, I see. It was just right in front of my eyes. Still expected two arguments and got one. Okay. Okay, because here it's not pair actually, it's make pair. That's the problem. And now we should be fine. Three tests, one failing. That is the one new that we created. 0,000, and we expect it to be west. Perfect. So now let's go ahead and fix that. So what I will need here is else if direction south, then direction will be equal to west. Let's go ahead, run our tests and see what we get. We have some build errors. Okay, let's go ahead and run our tests again. And perfect. All tests are passing. So now I have confidence to move ahead and do the next test. That is, if I turn the rover 4 times, I should be back at north. So exactly, one missing test. So now you go back here to rover and we add the last part. Direction equals west, then direction equals to north. Let's go ahead and run our tests. And once again, I'm forgetting the semicolons. And all green. We are good to go. So now that we have tested rotation to the right, I would say let's go ahead and test rotating to the left. So to rotate to the left, if I rotate to left 1 time, I should be at west. So let's go ahead and run our tests. Alright, one failing test. Says it's giving you north while it wants west. So now what we need to do? What we need to do is if the command now is equal to left, then similar logic. If direction to north, then the direction should be equal to west. Let's go ahead, run our tests. Once again, forgetting the semicolons. And everything passes. So now, for the following tests, actually, since I can see that this will be very similar to what I have done to the right, I have more confidence that I can do this at once. So instead of a smaller step, I'll take a leap and try to do a bigger step. So let's say I will include all of these tests straight away, left, which means that if I turn left twice, then I should be at south. If I turn left 3 times, I should be at east. And if I turn left 4 times, I should be back at north. So now we expect a few more failing tests. Let's go ahead and see what they get us. Okay, let's call them more. And we were right. So we have 3 failing tests that were the 3 new tests that we had. So let's go over to Rover and fix this real quick. So here what I will do is else if direction equals west, then direction should be equal to south. Here it's like this. Now else if direction equals to south, then direction should be equal to east. And else, but this else that I wanted is this one. If direction equals to east, then we can get back to north. So let's go ahead and run our tests. Everything green, so perfect. So let's stop for a little bit and see what we get, what we have. We have a test class that at the moment tests for a rover initial position is at 0 and facing north. Okay, and then here is no longer rotates right, I would guess is that the rover rotates. And we are testing every possible rotation that the rover can do. So right 4 times, left 4 times, and we are good. On the rover class, we have the execute method as a public interface. That's what we expected to. And here we have our logic to rotate the rover. However, I kind of feel that this direction doesn't really belong here, and especially this part of the code too doesn't belong here. So let's take this opportunity to do a little bit of refactoring. So first thing that I will do, I will use our handy VA to extract methods and call it rotate right and extract this. All right. Second, I'll do the same for the left. So extract method rotate left, right? And now in theory, since I use an automated tool to extract the methods and I didn't change any of the logic, my tests should still pass. And this will give me confidence on my code that I didn't break anything. All right, perfect. So now for the second part, what I would really like to do now is to remove this rotation logic out of the rover class. So let's play around a little bit with this idea. What I would like to see is I would like to have some kind of direction class, and now let's call it class direction. That does not exist yet. And from this class direction, I would ideally call a method right, and this will rotate my rover. So what will this look like if I follow through this actual implementation? Let's use VA to create a file. Let's say direction.h, and I'll say include new file. Now on this direction.h, I want a class called direction. I won't be needing this. I won't be needing this for now. And I want to have some methods called right to turn the rover right. Now what I'm missing is I need to create a file, and VA is smart enough to tell me it's a CPP file. That's just about right. And I want to create those method implementations. All right, perfect. So now if I go back to my rover class, it says there's no member right. And he is absolutely right. I made a mistake here. So now if I go back to my direction class, all right. So in theory, since this doesn't do anything, if I run my tests, this should still pass. Yes, perfect. So all green. So let's continue exploring this direction. So now what I will really want is that I've turned right, my direction would be equal to this direction new value. Right? So here I would say it's a char get value. And for now, let's make it return north. So what I expect now is my tests to fail if I run them because direction is returning north. All the rest should be fine. Yep. So let's go ahead and fix that. I will need some kind of, let's say, current position variable, and this current position variable would be instantiated north, and here instead I will return the current position, and our rotate right method will be something along these lines. Now instead of direction, it's current direction. And let's go ahead and comment this line of code. And if I did everything correctly, we should have passing tests. Yep, success. So what this means is that I can get rid of this, and I can get rid of this with total confidence that I haven't break any logic in my application. So now, since it worked so well for the left, let's go ahead and do the same for the right. Sorry, for the right, let's go ahead and do the same for the left. So I will want left method. Once again, handEVA to implement it. And now left should be similar to this method, but using current position instead. And if you go back to rover and we say that C direction left, and that the direction now equals the C direction get value, my tests should still be all green. Yes, so everything green, which means I can get rid of this, I can get rid of this, and my tests should still be green. All green. Good. So I can actually now also get rid of this and this and this and some synthetic sugar. And here use C direction dot get value. And now let's use handEVA again to just change this to direction. And to confirm I haven't break anything, green tests. And what we end up with is we haven't changed any tests, so we are sure that our business logic is still the one that we wanted from the initial tests, which is great. I have a rover class that's now, I can also get rid of this because we don't need it anymore, that just has a public interface to execute some commands. I have the rover class implementation that has a direction. And a direction class which will turn the rover right left and get its value, and the implementation of direction. Of course, I could still continue with this refactoring by moving this probably to a single method, let's say rotate, then those two will use, but for the purpose of this webinar, I think it's good enough. And this was it for showcasing test-driven development. I hope everyone enjoyed, and I will be available for some Q&A now. Thanks. Hello, everyone.
Hi there. Sorry about the confusion, everyone. It looks like our audio is playing up a little bit. So the GoToWebinar platform is a tiny bit shaky at the moment. My name is Ian Barker, and I'm the developer advocate. You often see me doing Embarcadero stuff, but I'm here as well for Holtomato. Today, you've already heard from him, but this is Nuno Castro, and he's the product manager for Visual Assist and Holtomato all together, I think. Is that right?
Yeah, that's right.
Yeah, there you go. You're an important guy. Okay, so we've got some questions. Let me just pull up the question log. Oh, I managed to dock it. Don't do that. I don't want you docked. Yeah, go somewhere pretty where I can read you. Okay, just want to thank everybody for asking the questions. Look, if our audio drops out, we apologize. It's nothing to do with us. Our connections are fine. Look, you can see us in glorious Technicolor, but there's something not quite right with GoToWebinar. There's been a few big outages across the internet. Microsoft had a few and things like that, so maybe it's all part of that. So Nuno, are there any particular questions you want to call out, or do you want me to pick a couple for you to just, we've answered them all, but I think it's worth discussing them again.
Yeah, I think there's one particular, I'm hearing echo, not sure if it's because of your, all right, yeah, much better. No.
Shouldn't
no.
hear an echo, but
okay, so I'll just go ahead.
Playing. Yeah, that could be what it is.
Yeah, I think there's one question that talked about like I know what CD is, but what happens when I have a project there's no tests and a lot of queue, so how could I test it? I think that's a good question and an important one to approach. And I would say that on those cases, first thing is, do we have an architecture that allows us to test every component individually? If yes, that's a big plus because we can go straight away and start writing tests for all of those components with the business logic that we want, just to make sure everything is working as expected. But often cases is not, and then it's the problem. And on those cases, normally what I would advise is start with end-to-end testing, something very broad that will touch all of the components of our applications and everything end-to-end. Do this for the major features of your applications, let's say the things that your users come for 90% of the time, and then grow from there. And from there, what you'll do is every little chance that you have to touch a piece of code because you're required to do a new feature or fix a bug or something, then you take an opportunity to refactor the code so it is better and easier to then write tests and maintain it. That would be my advice.
Yeah, and I had a couple of people, Marcus, hello Marcus, he's actually an MVP, but also normally he does Delphi stuff, but he's into C++ as well. He was mentioning about GUI testing, saying Ranorex was the thing. We're an Idea company, Holtomato are an Idea company, Embarcadero an Idea company. We're all brothers and sisters. I don't know however you want to genderize these things, but And RannerX is also an IDEA company as well, just as a little disclaimer there. But he also mentioned SmartBears, Test Complete, and a few others as well. Yeah, for GUI testing, it depends on whether it's web or desktop. There are lots of different solutions out there. I've used most of the ones that are on the market, and they all have their benefits. And SmartLook was one that I used for the web, and that's nothing to do with IDEA, but I found that very good as well. The other question was about A/B testing, and someone I brought up a question and said they were asking about end-to-end testing and what that meant, and we both answered, and I think we both said the same thing. It means about testing at the very end when the customer's actually got the product in their hands, as well as testing at the start when you're writing the code in the first place, test-driven development. But they were asking what A/B testing was. Do you want to just answer that for a second?
Yeah, sure. So A/B testing is when you have two possible ways to solve one problem, and you don't know exactly which one will have more success. So basically, one thing that you can do is you split up your user base. It can be in half, or you can just take, for example, 10% of your user base to do one way, other 10% to do other way, and you give it a test. Someone you give test A, some others you give test B. You measure performance, you see which one goes better, and then you decide and choose, and you roll out to everyone else's. And when I say which one performs better, it's not in terms of, it could be in terms of actual performance of a computer, let's say, or a server or anything, but when it performs, it can be on anything more broader, like which one had more interactions, which one sold better in marketing, which one the users engaged more. So it's this kind of testing that we are looking for with A/B testing.
Yeah, it's a bit like I think it was Coca-Cola, one of the soda companies. I actually was walking down a beautiful river in England, and they pulled me in, and they basically did A/B testing. They were bringing out the new improved Coke or whatever, and they had a bunch of glasses, and they said, one of these is the new recipe and one is the old recipe. Tell us which one you prefer, and you can't tell which one it is. But that's exactly what A/B testing is. You may have two solutions are perfect, but you don't know which one your users will prefer. And it's at the end of the day, like I do as a developer, sometimes there's more than one way to solve a problem.
Exactly.
And you go, this is the right one, and someone else says, no, I think my solution's better. And actually, they both have equal merit. And sometimes it's just down to user preference and luck and a few other things, whether A or B is the right answer. So that's what A/B testing is. And the other thing we mentioned as well is that you can put in-app metrics inside your app. You have to tell the user you're doing that, but in most countries you can't just silently do these things. But to actually gauge, look, are they ever going into this dialogue that we're thinking about redesigning and spending a lot of money on redeveloping? Because if they never go into it and they never use that option, there's no point in spending $50,000 or whatever of labor to try and rewrite something nobody ever uses. It could be nobody ever uses it because you do need to redesign it, but it could just be that you think people are using a feature and they're not. And this is very common on things like web apps. Facebook do it all the time. And Marcus was complaining about the agile circle. Marcus is like that. Yeah, he is very precise about things, shall we say. But actually, really, agile is the embodiment of what Facebook used to say, which was they used to say, move fast and break things. But actually, the whole point of your presentation was to say, move fast, but don't break things. And now, funny enough, that's exactly what Facebook says. They're like, we try not to break things, but moving quick is important. So, yeah. Yeah, okay. I think we answered most of the other questions. Is there anything else you want to add before we go? Because we're risking the wrath of the GoToWebinar audio gremlin.
Yeah, just to finish, I would say that if you haven't tried test-driven development, give it a shot. Especially because, for example, for me, before I was doing test-driven development, you have that kind of anxiety when doing some code sometimes, like you are afraid of changing something that will break everything. And with TDD, this kind of anxiety goes away because you always have your tests to confirm, like, are I moving in the right direction or not? And if you're moving in the right direction, yes. If not, okay, too. I can just revert back and play with another idea. So it allows me to have a playground where I can safely play and try out ways of doing different things in my codes without me knowing that I'm not breaking anything important.
Yeah, and in fact, we didn't edit out any pauses in the video deliberately. I mean,
Yeah,
we
exactly.
could have took out the pauses. We could have took out bits where people go, where's my semicolon? But you know what? If you're going to show coding like this, I think it's important to show genuine coding where you go, oh, now what have I done wrong? Because the test is telling you something's gone wrong. If it just everything worked slick and we polished it, then you know, I'm not sure it would be a particularly valuable webinar. You know, you want to see people struggle a bit and go, "Oh, I am mortal. I'm not a perfect robot." You know, it's good.
Yeah,
All right.
in this
Well,
case, that's exactly right.
yeah, exactly. Yeah, and I know your work anyway. I know you're very talented anyway. But I never claim to be talented. I'm just adequate. That's all that really matters. I can talk a lot. That's a good thing. Okay, well, thanks a lot, Nuno. Really great webinar, and thanks to the people that came and asked all your questions. And oh, actually, are you actually doing tests first before implementing the solution, or are you retrofitting tests to your solution in practice? Michael Kallenbach says.
I'm actually doing tests first. So the way that I see it is, what's the outcome that I expect? And that's the first thing that I need to figure out. Like, what is it that I want this code to do? And once I have it, then I start coding. And
Yeah,
the test is what will tell me if I'm already done with I am supposed to do.
yeah.
And that's the way I do it. I will
In my
retrofit if in cases like I take a legacy app, and then
yeah,
I have another option to retrofit. But that's what I
yeah.
normally use.
And in fact, in my experience of working with lots of entrepreneurs in my past career, I mean, not always, I worked in quite a few large software houses as well, but entrepreneurs are always like, you know, a bit kind of everything now, and they want it now, and they want it, you know, get it ready. And so they have this kind of mentality, a lot of them, where they just think that tests are unimportant. And yet, the minute you release the product and there's a problem with it, they suddenly think, why didn't you test this or whatever? There's no real compromise. You know, if you have to put tests in, whether you like it or not. Some people think that agile and tests and those kind of test-driven methodologies are kind of fashionable and they're not. You know, if you're producing a product at scale, then you know it's okay when it's just you and just your program and it's like a couple of screens and you know everything about it. But even that doesn't guarantee that it's bug free. And you know, one good bug in an application can be the death of the application. We've all used products where we go, oh, click it and it doesn't work, and that's it. You go, that's it. That's the end. I'm not going to use that. It's full of bugs. So you know, I think that you know, testing is one of those things where some people don't agree with it, but I do, and I've been a developer for 40 years. I know you do as well, and you know, what can I say? It's someone said. I've answered this question on chat already, but will there be a link to the recording session? Would it be sent by email? Yes, we always get this question asked, which is why I answered it in chat, but you'll automatically get an email with the replay on, hopefully including this Q&A. We're not 100% sure whether that will record. How many people were thinking of a better solution during the session? I was, yes, of course. Yeah, I mean, you know, the whole
Me
point
too.
about software development is it is part science and part art. And the bit that's part art is the bit where everybody disagrees. You know, and oh no, you could have done it this way and you could have done it that way. If it was purely scientific, there would only be one answer. You know, that's science for you.
And there's other thing that is perfectly fine. And the purpose of this is saying that if you are thinking of a better solution, you are free to try it because you know you are not going to break the business logic. That in the end, that's what matters. So go ahead, give it a try, and in the end, just click the button, and if it's green, deploy it.
Yeah, and Michael Callenbach follows up with a question and says, okay, how do you prevent overfitting to the tests at the expertise of generalization, e.g. just checking test cases in production code, not accounting for the full spectrum of possible inputs? It's kind of what the tests are there for, really. It's the second from last one if you're looking down the questions.
Yeah, I'm looking.
Very bottom, Michael Callenbach. Basically what he's saying is, how do you prevent doing too many tests and not actually thinking about the final solution that goes out to the customer in a kind of more generalized sense? And I think it's a difficult question, because the answer is, you know, that's why you have end user testing as well, and end-to-end testing. But you start with the user story anyway. You know, I am a user, I want to do X. Like, for example, if we were talking about GoToWebinar, I am a company and I want to present my webinar presentations. I want to be able to know who's attended those. I want the attendees to be able to ask questions. I want to be able to post messages in a chat that isn't part of the questions. And I want to have the presenters be able to show video, and I want them to be able to have their own cameras and microphones. These are the different user stories that you have when you design a feature. So if you're not actually meeting the requirements of the idea of a user using your product, you're missing the whole kind of whole solution there. You know, tests are part of getting to the point where the user story is fulfilled.
And actually, there are two schools of TDD. It's let's say the Chicago school and the London school, or the classicist versus the outside-in school. And the Chicago, the classicist school, what they say is you start doing from tests from the core of your application, so very small increments, one by one, and then the architecture will emerge. And then you have the outside-in, the London school of TDD, where they say that they start from the outside. So in that case, they actually go a little bit more broader. They ask some questions first. What's the user case? What's the goal of the application? So they can design a little bit up front and take some design decisions regarding your codes, like the thing that you are saying, like if you are doing an application that we know that will be potentially for 1 million people, so maybe there are some decisions that we want to do a little bit different. And on that school of TDD, you start a little bit from the outside and you do a little bit of an upfront design, so you face problems like this one that Michael was asking. Now, neither one practice is better than the other. They just suit different purposes, and you can switch between one and the other in your daily days work, depending on the task that you have in hand.
Yeah, and sometimes actually it's good to lay out the user interface first to get an idea of what is it that you're going to ask people to do when they're using this particular feature or this particular product. Because it is, for me particularly, I specialize in user interface design and user experience design. And so for me, an application is all about what is this user going to do with this app? What do they want to get out of it when they're using it? And then everything comes back from there. So I guess I'd be the second example that you're giving, which is, you know, tell me what I want this app for, and then I'll work out how I make that happen. Whereas the other school of thought is, I want to have something achieved, you know, that ends up with the user using it to solve a particular problem. So they're exactly the same in some ways, but also they're actually quite different because they're just you know, other ends of the coin. But I've worked at places that do both, and yeah, it's fun. You know, I mean, user experience is one of those things where just when you think you've got the perfect user interface, as I said in the comments, someone comes along and goes, click, and they do something you said, no, it would never happen. They'd never click on that button. They'd never do this. They'd never enter that value. And then they do. They go and enter it, and the whole thing goes wrong. So, you know, it's
Yes.
there's no such thing as a proof system.
Yeah, and on my presentation, when I was talking about the difference between design thinking, waterfall, and agile, was exactly more or less this: is like there's not really a right or a silver bullet approach for you to solve all kind of problems, and there's value in anything that you do. You just need to pick, let's say, your weapon according to the fights that you are having.
Yeah, that's a good point. Don Norman, who is the kind of uber saint of user interface design, one of the things that he says is there's no stupid users, there's only stupid user interfaces. So if someone can do something with your application that wrecks it, it's not their fault. Because too many, I mean, obviously, you know, like if someone sets fire to their computer and then says my word processor isn't working, well, that's not really your fault, is it? But generally speaking, if you can do something in an app that ends up being a problem, you can't really blame the user. It is down to you need to test, as Michael says, all of the angles, but also say, you know, what's the typical user using? Because there are so many possibilities for edge cases, you can't write tests for everything. But what you can do, write tests to make sure the business logic is sound, and that generally speaking, all the things that should happen and have rules and meaning to what's happening is tested. And that's what TDD does, test-driven development, but also just Agile in general is designed about getting to market. You can spend the entire life, your entire career designing an application and getting it perfect. But if you never release it, you're just a very expensive research organization, and your employers will not thank you for that. You know, you've got to, at the end of the day, someone's got to use it. You know, it's what it is. Okay, well, thanks a lot, Nuno, and thank you to all the people asking questions, particularly Michael. You asked some very good questions there, and Marcus and Daniel and a couple of the others as well that asked questions. I think we're okay. Are we good to go, Nuno? I think we are. All
Good to
right.
go.
All right. Well, thanks very much, Nuno. We'll see you next time. And thanks to the audience as well. Replay will be, you'll get an email and probably tomorrow with the replays, and then we'll see you again soon. Thanks for joining us.